बिस्मिल्लाहिर्रहमानिर्रहीम नहमदुहु व नुसल्ली अला मुहम्मद रसूलुल्लाहि करीम. This problem is related to partial differentiation of differential calculus. Verify that del 2z over del x del y is equal to del 2z over del y del x when z is equal to x to the power y plus y to the power x. For this we will find the first left hand side and then right hand side. For left hand side we first differentiate with respect to y and then x. Differentiation of z. Z is given here. Z is equal to x to the power y plus y to the power x. I write it as a equation number 1. And for this value left hand side we should differentiate partially this value with respect to y. Differentiating equation 1 partially with respect to y. So differentiate z with respect to y, we will get in left hand side, and differentiation of x to the power y with respect to y, and also differentiation of this term with respect to y, y to the power x. This is nothing but constant to the power variable because it is partial differentiation. For partial differentiation x is constant for y. Only y is variable here in this function and also in this function. So it is constant to the power variable, and here it is variable to the power constant. So on here and here apply different formula. For this we should apply this formula. I write it in x. Differentiation of x to the power n is equal to nx to the power n minus 1, because it is x is variable, n is constant. It will apply in second term, but for first term we should apply this formula. A to the power x means constant to the power variable, which is equal to a to the power x into log a base. This formula will apply in first term, and this formula will apply variable to the power constant. Variable to the power constant apply here. So I write in next step del z over del y is equal to, by this formula constant to the power variable is equal to constant to the power variable equal to this term here x to the power y, and log a base is same. Here base is x. So I write here log x plus, now differentiate this value, variable to the power constant, variable to the power constant. Here x is variable, so this power is here and power will reduce by 1. So I also apply this formula in here. So x, which is power of y, which will multiply like n, and y to the power x equal to x minus 1 according to this formula. Now we have to find left hand side by differentiate this value again with respect to x. So I write differentiating this value, this equation, differentiating this equation y partially with respect to x. in left hand side we will get del 2z over del x del y. Differentiation of del z over del y with respect to s is equal to this, and on right hand side we will differentiate this term and this term according to linear property of differentiation. X to the power y into log x, first term differentiation, and second term differentiation with respect to x. Now we will consider in first term, these are multiplication of two functions, first and second. I consider y to the power x as first function and log y second function, so apply product rule. First function as it, differentiation of second, plus second function as it, differentiate first function. Also apply formula product rule here. Consider x as a first function and y to the power x minus 1 as a second function. First function as it, differentiation of second, plus second function as a differentiation of first. Now differentiate these values. We will get right hand side x to the power y into differentiation of log x is equal to 1 upon x plus log x into differentiation of x to the power y, which is case here variable to the power constant, so this power will multiply here y and power will reduce by 1. This is differentiation of this term. Now we go to next term here, x, write x and differentiate according to this formula, because it is for x y is constant and this is variable, so differentiation, so write apply this formula, constant to the power variable, we get y to the power x minus 1 and multiply log y according to this formula. Here is base of x, so log will come with a, and here it will come with y, plus I will write this value y to the power x minus 1 and differentiation of x with respect to x is equal to 1, because here x to the y divided by x, here degree of x equal to 1. If we write x only, then power will be subtract from y from 1 from y, and x it become x to the power y minus 1 as you know, plus I will write x to the power y minus 1 first and then y and then log x, and also x y to the power x minus 1 log y, and y into 1 equal to y to power x minus 1. This is value of del to z over del x del y. Now we will get left hand side which equal to del to z over del x del y equal to I write this value x to the power y minus 1 plus y to the power x minus y, and write these two terms x to the power y minus 1 y into log x plus x y to the power x minus 1 log y. it is equation left hand side, so I write it as equation number 2 because we already write equation number 1 here. And now we will go to find the right hand side, which is, so we will differentiate with respect to x first. So differentiate equation 1, differentiating equation 1 with partially with respect to x, we will get in left hand side del z over del x, and these two terms will differentiate by x to the power y, and differentiation of y to the power x with respect to x. Here x is variable, so variable to the power constant and constant to the power variable. Only these two formulas will use in whole questions solution. So variable to the power constant is this formula. I will use this formula. So this y is multiplied here, and x to the power y minus 1 according to this formula, and constant to the power variable is equal to this value, like write as it, and log of a. So I write y to the power x as it, and log y. This is value of del z over del x. What we have to find del to z over del y del x. So for right hand side, we should differentiate whole equation with respect to y. Differentiating last equation with respect to y partially. In left hand side we get d2z over del 2z over del y del x, and right hand side there are two terms, so differentiated with respect to y. First term is y x to the power y minus 1, and second term is y to the power x log y to the power x into log y. But here we see that there are two terms of y, so apply product rule. First function as it, differentiation of second function, plus second function as it, differentiation of first. Apply also this product formula for this functions. Consider y to the power x as first function, write first function as it, differentiation of second function, plus write log y, first function as it, differentiation of first function. In next step, y multiplied by, here it is constant to the power variable, because y is variable, because it is partial differentiation. So apply formula which I write in second place. So I write it is as y to the power x minus 1 into log x to the power y minus 1 log x. I apply formula, plus x to the power y minus 1, and differentiation of y with respect to y equal to 1, plus here y to the power x, and differentiation of log y with respect to y is 1 upon y, plus log y into differentiation of y to the power x, which y is variable, so therefore variable to the power constant, so power will come here, and power will reduce by 1 according to formula. I write x to the power y minus 1 is here first, x to the power y minus 1 and also y to the power x minus 1, because here is y to the power 1, and on division power will be subtracted, so y to the power x minus 1. And write these two terms. I write like equation number 2. So here x to the power y minus 1 first. So I write x to the power y minus first, and then y and log x, and after it I write last term and write x first and y to the power x minus 1 and log y. This is value of del 2z over del y del x. I write it as equation number 3. From equation number 2 and 3, we can say that del 2z over del x del y equal to del 2z over del y del s, because right hand side are equal from both equation 2 and 3, so left hand side also equal, hence verified. Thank you very much indeed for listening me. Wa akhiru da'wana alhamdulillahi rabbil alamin.